We are analyzing measures of central tendency. I know that sounds like a foreign word, but it's stuff that you've been doing for a while. It's mean, median, mode, and we'll even talk about range a little bit. But for the most part, the measures of central tendency for right now are mean, median, and mode. We'll get into standard deviation and stuff like that later. So in order to find the mean, what is the mean? It's the average. So if you don't remember that, might write it in. If you don't remember it even after you write it in, there's a little picture on my wall there of a nice little song that goes to the tune of "The Cow Jumped Over the Moon." Hey diddle diddle, median's the middle. You add, then divide for the mean. So it even tells you how to do it. Okay? Obviously the median, like I just said, is the middle. Just like when you're driving a car, the median is the grassy part normally in between the two directions of traffic. And the mode is the one that, what? Occurs the most. And the range is the difference between.
Can I just switch a line with this on this? Just doing it.
Yeah, I mean, okay. Alright, for the mean, we add and divide. Okay, we add them all up and we divide by the total number that are there. The median, these have to be in order, so put in parentheses, in order. It's a common mistake I see, that people will just take it as is and they don't put them in order. So before you find the median, the middle, you have to have the numbers in order. And on the mode, you can have more than one mode. The rest of them, you only have one of those. Okay, but you can have more than one mode. It's just the number that occurs the most. So if I have a 2 that occurs twice and a 5 that occurs twice, they are both the mode. Okay? So let's jump right into some examples on example 1. This is quite a bit of calculator work, so you got to be very careful. Example 1 says find the mean, median, and mode. And I want you to get in your calculator. I downloaded an app in there just in case, well, I don't have it on my calculator. It says app for math. So click the app button right here, and you should see something that says app for math. Anybody not find it?
I clicked on it.
Awesome. It should open up and it'll say it at the top, something.
It says Zoom Math.
Zoom Math. That's the product name, is Zoom Math. So you should see that at the top. It'll help you later on if you mess up. Okay? So if you mess up, you'll just press the tab up button. It'll pull up all of your numbers, and you can go and change it if you accidentally typed in the wrong number. So finding the mean of the first one, I'm going to let you guys do the calculator work, so be typing it in, is we add them all together. So here are the numbers, and I'm going to put them in order as I write them down, so that when I do my median, I can already see them in order. So here we go. The smallest number there is 33. I have 2 of those. So I have 33 plus 33 plus, I have 34, plus I have 1, 2, 3 35s. 1, 2, 3 35s. I have 2 36s and a 38. And then I go back through there to make sure that I didn't forget any numbers. I count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there were 9 numbers in my original, so they are indeed in order. When I add all those together, how many, or what is the number that I get? 315? Okay, good. Now I added them all together and I divide by the total number that were there, and there were 9. So I have to take 315 and I divide it by 9. And what is my mean? My mean is 35. Okay, I would say that this is most likely going to be your most accurate measure of central tendency, is your mean. Okay? Next, I want to look for my median. That's my middle number. And then I will look for my mode. Because of the way I do it, I find my mode first. Okay, but I only write them in this order because when I say them out loud, I always go mean, median, mode. I don't know if it's the OCD in me that says I have to do them in alphabetical order or what. But anyways, mode is the one that occurs most. What occurs the most? 35, so that one's obvious. The median. Now there's lots of different ways to find the median. It's the middle number. Okay, so I can do this. I can mark them off one at a time. Okay, so I just cover them up like this, or I can mark them off with my pencil. I don't care what you do. So I just cover them, cover them, cover them, cover them. So my median is also 35. What if I had two numbers as my median? There's two numbers in the middle. I need to take my two numbers and I find the average of them. If I have two medians, I find the average of them. Okay? Here's a quick way to know what number is going to be your median. I say quick, but it makes sense to me. So I take, if it's an odd number, I divide it in half. So if it's 9, I divide it in half, and I get 4.5. Okay? I would round this number. Round it. Okay? So it's the fifth number in the sequence. Now watch. 1, 2, 3, 4, 5. And it is the one that I'm looking for. Okay? So I would round my number. If it was 11, if I had 11 numbers, I would divide it in 2, and I'd get 5.5. I'd round. It's the sixth number. Now, if it's an even number, for example, 8, okay, I would again divide it by 2. I'd get 4, and because it's a whole number, I know that I have to find the median is going to be two numbers. Okay, because it's a whole number, I know it's going to be two numbers, so it's going to be the fourth and fifth term that I have to look at, and then I have to find the average of them. Okay, so if it were 12, it would be the sixth and seventh term that I would have to find the average of. Okay, that's just the way I do it without having to count all of the numbers. When you're dealing with big sets of numbers, it makes your life a lot easier. It eliminates error. So there's example 1. Relatively simple. We have to remember to put them in order. If you put them in order when you add them together, then you don't have to do it twice. Okay, example number 2. They give us a lot of numbers here, guys, so you have to be very careful. Okay, the table lists the total points teams scored in two divisions of the All-Star Football League in the 2006 regular season. They divide them by north and south. Okay, so there's your chart. You should be staring at it. It says, does the north or south have the greater range? So the range is what? Say that again. It's the difference between, right? The difference between what? Right. Difference between biggest and smallest. The highest and the lowest. Whoops, forgot to write and in there. So it's the difference between the biggest and the smallest. So for this example, we're going to look at the north. And I want you to go through there and find the smallest number. When you find it, let me know. 211. Did anybody find something smaller? Okay, now go through there and find the biggest number. Levi, what is it?
The biggest number?
Yeah.
425.
425. Did somebody find one bigger?
427.
I did too. Any other numbers? Okay, so I'm going to take the biggest one and I'm going to subtract it from the smallest one. When I do that, I get 216. So for the south, I need again to find the biggest and smallest number. So Levi, what's the biggest number? 492. And my smallest number?
168.
Anybody find one smaller than 168? Okay, and the difference between those two is 324. Good. So now I have to compare the two. 216 is what to 324? It is less than 324. So there you go. To answer the question, we have to make sure that we specify which one is the smallest. So it says, does the north or south have the greater range? So who has the greater range? South. The south has the greater range. Okay? We're going to talk about what an outlier is real quick. So if I look at the data that we just went over, okay, in the south they have numbers like 385, 492, and then they have this one that's like 168. It's a number that sticks out because it doesn't fit the rest of the numbers. So if I have a whole bunch of single-digit numbers, like 1, 2, 4, 7, and 9, and then I have this number that's like 35, it's an outlier. Or if I have numbers like 35, 36, 37, 39, 42, 17, and then I have a number that's negative 15, negative 15 is going to be an outlier. Okay? There is a specific process for finding outliers, or for the time being, we're going to identify them by how strange they look with the rest of the numbers. Okay? So in example 3, we're going to identify an outlier, if there is one. Okay? So since the following data shows the high temperatures in degrees Fahrenheit for the first 15 days in July for Seattle, Washington. Look at that set of numbers. Okay, what is the biggest number? 98. I will give you this. An outlier is always going to be the biggest number or the smallest number. Okay? What is the smallest number? And you can have more than one outlier. Okay, so let's look at these numbers and see which one sticks out the most. Does 75 stick out much? No, because it has 76, 78, 79, and they're really close. Does 98 stick out very much? Yes, because the next closest one to it is 89. Okay, so the outlier here would be the number that is farthest away from any of the rest of the data set. So 98 is our outlier, okay, because it is much greater than the rest of the numbers in that set. Now it says, describe how the outlier affects measures of central tendency. This is where you're going to use this app for math. So let's use it to our advantage. I'll say the numbers out loud so you can type them into your calculator. Make sure you're in the app for math. Here we go. 75. You're adding these all together, okay? Plus 76, plus 78, plus 78, plus 78, plus 79, plus 81, plus 81, plus 81, plus 81, plus 81, plus 84, plus 86, plus 89, and plus 98. Okay? The reason I say that this app for math is going to help us, press enter on that. What number did we get? 1,300? 226. Okay, so I want to find the mean, median, and mode with the outlier included. So here we go. Mean, median, mode. And I'm going to put this as a with right here. I'm going to annotate that it's with the outlier. Okay. So to find the mean, I take this number that I just added together, and I would divide it by the total numbers that are there. How many numbers are in that data set? It said they took the first how many days? 15. So I'd take this number and divide it by 15. What do I get? We're going to round it to the nearest degree, by the way. 81.7, so it's 82 degrees. I think that was in Fahrenheit. So there we go. Looking at those numbers in order again, I need to find the median. So I'm going to blow them up real quick and see if I can see them a little bit better. It's kind of hard to see. See if I can. Okay, so here's my data set. Since there are 15, I know, because I'm going to divide it by 2, I'm going to get 7.5. I'm going to round up. It's going to be the 8th number, so I'll just count. 1, 2, 3, 4, 5, 6, 7, 8. My median is 81 degrees Fahrenheit. Also, what is my mode? 81. It occurs a bunch of times. Okay, so this is with. Next one we're going to do without. We're going to find the mean, median, and mode of it. So this is where your app for math comes in handy. Press the up button on your calculator twice. It should pull up the exact set of numbers that you just added together. Okay, just delete the last one and then press enter and tell me what you get. 1,128. Now if you're not using app for math, you just take your previous number and subtract the outlier from it, which would be 98. Okay. Now since we deleted one of the data set, one of the numbers out of the data set, what am I going to divide it by now? 14, because I only have 14 numbers in my data set, and that gives me, and again I'm going to round this if I have to the nearest degree.
80.571.
So 81 degrees Fahrenheit. Again, I need to look at my median because now I have 14 numbers in my data set. I'm going to take the 7th and 8th one and find the average of it. So here's my data set. I'm going to take the 7th and 8th one. So 1, 2, 3, 4, 5, 6, 7, and 8. That was nice. It's pretty easy if they're both the same number. So 7 and 8 were both 81. I add them together, I divide by 2, and I still get 81. So 81 degrees Fahrenheit. And my mode, obviously, still 81 degrees Fahrenheit. Okay? So when I talk about this, and this is what your answer is, okay, all of this is just stuff to support your answer. You have to have it. But to actually answer the question, we have to talk about them individually. So the mean changed by how much?
1 degree.
1 degree. Not a whole lot, but it did change, right? So with the outlier in it, the mean changed 1 degree. The median and mode did what? They stayed the same. So in words, you would say the value of the outlier raised the mean by 1 degree. And then you could say that the median and mode remain the same. Okay? Any questions on how to write that in words? Example 4, application of advertising. A Supergrow fertilizer placed this advertisement in the newspaper. Is the statement in the advertisement true? And does the statement accurately describe the data and explain? So, I will give you a hint. This has to do with an outlier of some sort. Okay? So here is the advertisement. It says, buy Supergrow today. Grow with Supergrow fertilizer, and it gives you these numbers. 10, 8, 8, 6, 5, 4, 7, 5, and 20. It says, grow with brand X. And then it shows the numbers they have there. 6, 7, 6, 5, 7, 9, 7, 5, 7. Okay? So it says Supergrow watermelons have an average weight of over 8 pounds. Brand X fertilizer watermelons have an average weight of under 7. So is it true, is what it's saying. And if it is not true, why is it not true? What do we notice about the data set up here? There's a massive outlier. What is it? 20. But look what happens. They have a number of 4 down here, so some of the watermelons are really small. Some of them are big. Here, they all hold a big average 6, 7 pounds. Okay? So, we're going to see if what they say is true without the outlier. So you're going to take all these numbers, the 10, 8, 8, 6, 5, 4, 7, 5, and we're going to find the average of them without the outlier. So take those numbers, add them together. And I'm going to count them how many data numbers there are in here. 2, 3, 4, 5, 6, 7, 8. Okay? So there's a total of 8 numbers. Without the outlier. We don't want the 20 in there. Because it's an outlier. It's just one of those anomalies. Just like when you go to the fair and they have this 200-pound pumpkin, but your pumpkins are only 10 pounds. So for Supergrow, what is the total number there when you add them together? What do we get? 53. And we're dividing that by how many were in the data set? 8. And our average is what? 6.65. Let's see what the average of the other company is at brand X. So take the 6, 7, 6, 5, 7, 9. Oh, I'm sorry. 6.25. Okay, let's find the average of brand X. I thought you told me 2.5. 6.625. Thank you. Let's find brand X. So add all those numbers together. And how many numbers are in that data set?
9.
There's 9 in there. So when we added them all up, what do we get? 59. So 59 divided by 9 is?
That can't be right.
What's it say?
It can't be right if it's 59 because the others have different numbers.
Not really. Yeah.
And that's how it's misleading, right? What is the number? 6 point what? 6.556. So these two numbers here are relatively close to each other. So their claim their claim is that Supergirl watermelons have an average of over 8 pounds. Well, of course they do. When you add 20 to this, we get 73 divided by 9 because we added in that extra data set. 73 divided by 9 gives us a bigger number of 8. So see how big that affects our outlier when you have a 20-pound watermelon? Okay, so is what they are saying correct? No, because why?
No, they average bigger than all.
Why is it not true?
Because it's not that many things.
Right, because that's an outlier. It's an anomaly in the data. Okay, so while what they're saying is true with the outlier, they have 8-pound watermelons. Without the outlier, it only shows us about a 6.625, which is only barely bigger than the other brand. Okay, that's everything.